Hey there, and welcome to this explainer. Okay, we're just going to dive right in today because we have a really clear goal. We are going to break down the actual mechanics of heat flow so you can absolutely ace those tricky science exam questions. If you've ever found yourself totally confused by how thermal energy moves, or maybe you've lost a few frustrating points on a test because you mixed up some basic definitions, well, you are in the exact right place. We're going to get this sorted out. To make sure we're zeroing in on exactly what you need to know, we're going to solve real exam questions today. And we're starting with this classic puzzle right out of your textbook. A car is sitting in a parking lot, just baking in the intense sunlight. The driver gets in, cranks the air conditioning, and the absolute moment that cold air hits the glass, the windscreen cracks. Why does that happen? Keep this specific mystery in the back of your mind, because by the end of our time today, you'll be able to answer it perfectly. All right, here's our study guide roadmap for today. 1. The myth, heat versus temperature. 2. Conduction. 3. Convection. 4. Radiation. And 5. Acing the exam.
Okay, let's hit part 1, the myth, heat versus temperature.
Literally, the biggest trap students fall into on test day is assuming heat and temperature are exactly the same thing. They're not. Let's break them apart, starting with heat. Heat is actually a form of energy. It's energy you get from sources like the sun, electrical appliances, or burning fuel. And here is the absolutely crucial takeaway. Heat always naturally flows from a hotter region to a colder one. It moves. It's a flow of energy. Temperature, on the flip side, is not the energy itself. It's simply the measurement of exactly how hot or cold an object is. So to get slightly technical for a second, temperature is really just measuring the degree of movement or the vibration of the microscopic particles inside that matter. Take a look at this comparison we pulled from the source material. It's practically a cheat sheet for your exam. Notice the specific SI units here. Heat is measured in joules with a capital J because, again, it's energy. Temperature is measured in degrees Celsius or Kelvin, and really critically, the amount of heat something has depends on the type and quantity of the material itself. But temperature, that relies purely on the speed of those vibrating particles. We actually see this dynamic play out every single day. Temperature goes up in a hot environment, like a pot of boiling pasta water on the stove, because it's actively taking in heat energy. Conversely, it goes down in a cold environment, like these bottled drinks packed in a cooler of ice. The heat physically flows out of the room temperature drinks and into the colder ice, dropping the temperature of the liquid. All right, moving to part 2, conduction. So how does heat actually travel? Let's start with conduction, which is how heat transfers through a solid medium. Picture this classic lab activity. You stick 3 thumbtacks onto a solid copper rod using little dabs of candle wax. Then you blast one end of the rod with a Bunsen burner. What happens next? Well, the particles right at the heated end get energized. They start vibrating wildly and smashing into their neighbors. These physical collisions pass the heat energy right down the line of the solid copper rod, melting the wax in order and dropping the thumbtacks one by one by one. So, solid medium plus physical particle collisions equals conduction. Now for part 3, convection. Okay, quick reminder, in science, the word fluid means both liquids and gases. You really need to nail these specific mechanics for your test. When a fluid is heated, it expands. Because it expands, it becomes less dense than the cooler fluid around it. And since it's less dense, it rises. At the exact same time, the colder, heavier fluid sinks down to take its place. This continuous, swirling loop of rising hot fluid and falling cold fluid is what we call a convection current. We can literally watch this current happen in a liquid. If you fill a beaker with water and drop a single purple potassium permanganate crystal right to the bottom, then slowly heat the glass directly under it, you'll see the purple dye expand, shoot up to the surface, cool off, and then sink right back down. It vividly traces the exact path of the convection current. And yep, we can prove it happens in gases too. If you put a lit candle on one side of a partitioned beaker, the air heats up and rises out the top. If you then hold a glowing, smoky incense stick over the other side of the partition, that colder, denser smoke actually gets sucked downward into the beaker to replace the rising hot air, traveling under the partition and up the other side. That is convection in action. Okay, part 4, radiation. This final method completely rewrites the rules. Unlike conduction or convection, radiation doesn't need any medium. No solids, no liquids, no gases. It travels freely through the total emptiness of space, which is incredibly lucky for us. Otherwise, the sun's heat would never make it across 93 million miles of vacuum to keep Earth warm. To prove this on your exam, you'll want to reference the bell jar experiment. You put a light bulb inside a glass bell jar, and then you use a vacuum pump to completely suck all the air out. So there is zero gas, liquid, or solid connecting the bulb to the glass. You turn the bulb on, wait about 10 minutes, and touch the outside of the jar. It's hot. The heat radiated outward from the bulb, straight through a pure vacuum, and hit the glass.
Finally, part 5, acing the exam.
Let's pull all this together and solve our puzzle, the hot car in the parking lot. So the sun's radiation has totally baked the solid glass windshield. When you turn on the AC, it suddenly blasts freezing air against the inside of the hot glass. Now remember the rule about matter expanding and contracting. The sudden shock of cold air causes rapid, entirely uneven contraction of the solid matter. The inside layer of the glass cools and shrinks instantly, while the outside layer is still hot and expanded. That immense physical stress literally rips the structure apart, and the windscreen clacks. By the way, a great real-world tip, roll down your windows first to let the hot air escape, or just start your AC on a low setting so the glass cools down gradually.
Okay, let's do a rapid-fire recap. Remember, heat is the energy that flows, measured in joules. Temperature is the measurement of particle jiggle, in Celsius or Kelvin. Conduction transfers heat through solid collisions. Convection moves heat through rising and sinking currents in fluids. And radiation beams heat without any medium at all, perfectly fine in a total vacuum.
All right, I'm going to leave you with this final higher-order thinking question to really test what you've learned. Based on everything we just covered about heat transfer and the expansion of gases, what dangerous reaction occurs if someone tosses a completely sealed, supposedly empty insecticide can into a burning rubbish dump? Just think about those residual gas particles locked inside. When they suddenly absorb all that intense heat energy, they start moving violently, right? The pressure builds and builds until, well, I bet you can guess the explosive answer. Thanks for hanging out with me for this explainer. Good luck crushing those science exams, and keep asking great questions.